Welcome back to module 6 of this unit 3, index numbers, and we will be talking about adequacy of an index number in this module. Recollect that we have talked about 3 types of index numbers in our previous modules: price index number, quantity index number, and a value index number. And we have also talked about different methods that are used in constructing an index number: a Laspeyres index number, a Paasches index number, and Fisher's index number. Of course, there are many more formulae that are usually which are also available in constructing an index number, but then we are talking about only these 3 methods. Now, given this index number, so in case we want to find out which is the most reliable method or which is the most adequate definition or formula that can be used in constructing an index number. Now, to verify adequacy of an index number, which is the most reliable one, there are some tests that are usually recommended. One of them is a unit test. So a unit test suggests that the formula that we are defining should be independent of the units. In fact, this is a test that is satisfied by almost all the index number method formulae that we have studied, except for only the first one, where we define the index number as just summation p1 upon summation p0 multiplied by 100. This was the only formula in which this test is not satisfied, because the prices, we just add the prices in the current year and we just add the prices in the base year and we take the ratio multiplied by 100. Otherwise, rest all formulae that we have talked about, they all satisfy this unit test. Then the second test that is recommended is the time reversal test. What it says is that the formula should work both ways. What we mean by that is, if I find out the price index number for the current year with respect to the base year and the price index number for the base year with respect to the current year, then P01 into P10 should be equal to 1. This is what the time reversal test requires. Then there is a factor reversal test. Factor reversal test says, because we know that the product of the price index and the quantity index, because the product of price and quantity is value, what it says is that the product of the price index number and the quantity index number should be equal to the value index number. So P01 into Q01 should be equal to V01. So for an index number to be adequate, this is a test that should be satisfied. Besides this, there is something called as a circular test. What it says is, suppose I am constructing an index number over a number of periods, say A, B, C. Then PAB, the price index number for B with respect to A, the price index number for C with respect to B, and the price index number for A with respect to C. If I multiply them, it should be equal to 1. So in a way, we are going in a circular: A to B, B to C, and then C to A, again A. This product should be equal to 1. In simple language, what it means is that the index number that we are constructing for period B, with respect to A, and for C with respect to B, should be the same result as index number for C with base A without going through B. This is what it means. If you see, this is just a special case of the time reversal test that we talked about earlier, because if I just take only 2 periods, say A and B, this test says PAB into PBA should be equal to 1. So if you denote A as 0 and B as 1, it is saying that P01 into P10 should be equal to 1. Now this is the time reversal test. So this circular test is just an extension of the time reversal test for more number of periods. So let us say I want to test this formulae, Laspeyres, Paasches, and Fisher's that we have constructed earlier. So for that, let us consider this example here. So I have 4 commodities here, A, B, C, D, whose prices are given over 2 periods. So 2010 and 2011. So 2011, let me consider it to be the current year, and 2010, let's say, is the base year. So we know the prices and the quantities in both this base year and the current year. So the prices in the base year, this is P0, quantities in the base year is Q0. So prices in the current year P1 and quantities Q1. Now this is the data that we have also, the same data that we have considered in the previous modules as well. So now our question here is to test Laspeyres, Paasches and Fisher's index number using these various tests that we have specified in this previous slides. Okay. So now for that, given this, we'll have to calculate, because we'll have to construct this index numbers, Laspeyres and Paasches and value index number. For that, we know that we have to construct this columns. Q1 P0, Q0 P0, Q1 P1 and Q0 P1. Now this is something that we have already done in the previous modules, so I'm directly using these values here. Okay, so that we do not have to calculate them again. Okay, so this value that we have is sum of summation Q1 P0. This is summation Q1 P0. This value is summation Q0 P0. Recall that this is same as P0 Q0. This is summation P1 P0 Q1. This is summation Q1 P1, which is same as summation P1 Q1, and this is summation Q0 P1, which is same as P1 Q0. These are the four values that we need in calculating all those index numbers. Okay, so I assume that these values have already been calculated by you, and we will be making use of only these four values. So I have noted down again the same values here: summation P1 Q0, summation P0 Q0, summation P1 Q1 and summation P0 Q1. And I have calculated each of the price indices and the quantity indices. So we know that Laspeyres price index number for current year with respect to the base year is given by this formula. Okay. So I have substituted summation P1 Q0 here and summation P0 Q0 here, and I have directly calculated the value. It comes to 124.7. The same way I have constructed price index number, that is the Paasches price index number for the current year with respect to the base year. This is the formula that we have worked with earlier. We already know how to calculate these things. So I have substituted summation P1 Q1, summation P0 Q1 here in this formula, and I get 121.8. So like this, we have calculated here all these values. The quantity, Laspeyres quantity index number for the current year with respect to the base year. Okay, this is the formula we know. I have substituted these values here. In all of this, we are using only these four values that we have been noted here. Summation Q1 P0. Okay, recall that it is same as summation P0 Q1. So it is summation P0 Q1 1470 here that I have substituted. Summation Q0 P0 is same as summation P0 Q0, which is 1660, substitute here. So this is precisely these four values that we use in constructing all the index numbers that we have talked about so far. So the same way we have calculated Laspeyres price index number for the base year with respect to the current year. Okay. So what will be the difference here? Now we are measuring index number for base year. So base year price is on top, current year prices are down, and this is Laspeyres. So it is using quantities in the base year as weights. The same way Paasches price index number for the base year with respect to the current year. So it is for the base year. So base year prices are here, current year prices are here, and Paasches uses quantities in the current year as the weights. Okay. Fisher's also we know how to calculate. The same way the quantity index number for the base year with respect to the current year. Okay, I've used the formula. We have already seen this before. I've calculated all these values. Okay, what we need is these values after substituting the formula, the values that we have calculated. Okay, so let us try use these values in verifying, testing each of these index numbers, Laspeyres, Paasches and Fisher's. So let us first test Laspeyres index number. A unit test, it requires that the units, the formula is independent of the units, and that is very well satisfied, because we know that Laspeyres index number is summation P1 Q0 upon summation P0 Q0 multiplied by 100. So in whatever units these prices and quantities are defined, the units will get cancelled because we are dividing by the same quantity. Okay. So unit test is by default satisfied by this Laspeyres index number. Now let us test for the time reversal test. Okay. So the time reversal test says that P01 into P10 should be equal to 1. Okay. So we are testing for Laspeyres. So let us consider Laspeyres price index number. Now we are taking 1 here. So that means the index numbers that we are considering here, we are considering it without the factor 100. Okay. So when we say Laspeyres price index number P01 is 124.7, without the factor 100 it will be just 1.247. So we will be using the values that way because the test is without those factors 100. So P01 Laspeyres into P10 Laspeyres, it is 1.247, okay, without the factor 100, and P10 Laspeyres, P10 Laspeyres is 80.2, which is 0.802. So if we multiply this will come to some 1.00094. Okay, so this is almost equal to 1, and that is the requirement here. So we can see that the Laspeyres index number satisfies time reversal test. Okay. Now let us check for the factor reversal test whether Laspeyres index number satisfies factor reversal test or not. For that, now the requirement is this. So we'll look at P01, we are considering Laspeyres, into Q01 Laspeyres. So P01 Laspeyres is 1.247 into Q01 Laspeyres. Q01 Laspeyres is 88.6, so it is 0.886. Okay, so if we multiply this, then this will come to 1.105. Okay, now P01 into Q01 should be V01. Let us calculate what is V01. How is V01 defined? It is summation V1 upon summation V0. So it is summation P1 Q1 upon summation P0 Q0. Now what is summation P1 Q1? It is 1790 upon P0 Q0 is 1660. So if we calculate this, then this will come to 1.078. So we have V01 as 1.078, whereas the left hand side P01 into Q01 is 1.105. So we see that they are not really the same. Okay, 1.105, and here V01 is 1.078. So because the values are not same, we see that the factor reversal test is not satisfied by Laspeyres index number, whereas it satisfies unit test and time reversal test. Now let us check for Paasches index number. So Paasches index number, if you recall, it is P01 Paasches, it is summation P1 Q1 upon summation P0 Q1 multiplied by 100. Now obviously here this is also independent of the units because the units will get cancelled. So unit test is satisfied by default. Let us check for the time reversal test. So we are looking at Paasches. So P01 Paasches into P10 Paasches. P01 Paasches is here. It is 121.8. So it is 1.218 without 100, the factor 100, into P10 Paasches. P10 Paasches is 82.1, so 0.821. If we multiply this, then this will come to 0.999978. This is almost equal to 1, approximately equal to 1. So we see that the time reversal test is satisfied because this product comes to almost equal to 1. This error is because of the rounding of these values that we had considered earlier. If you take more number of digits in these values, then this will come more closer to 1. Now let us check for the factor reversal test. So factor reversal test says that P01 Paasches into Q01 Paasches should be equal to V01. Okay, and V01 we have already calculated in the previous slide. It was 1.078. Let us calculate this. P01 Paasches. P01 Paasches is here 1.218 into Q01 Paasches. Q01 Paasches is 86.5, 0.865. Okay, if we multiply this, then this will come to 1.0536. And what was V01? V01 is 1.078. Again we see that there is quite a difference. Of course here now the difference is much less as compared to the Laspeyres in the previous slides, but then it is not really equal. So the factor reversal test is also not satisfied by Paasches index number. So this is not satisfied. Let us go to the Fisher's index number. Okay, Fisher's index number is a geometric mean of Laspeyres and Paasches index number. So obviously it satisfies the unit test, because we know that Fisher's, Laspeyres and Paasches, they satisfy this unit test as well. They are basically independent of the units. Now let us go for the time reversal test. So the time reversal test requires that P01 into P10 should be equal to 1. So let us check for the Fishers. So P01 Fishers into P10 Fishers. So if we substitute these values, P01 Fishers is 123.24. So it is 1.2324 into P10 Fishers. P10 Fishers is here. It is 81.14. So it is 0.8114. If we multiply this, this will come to 0.99997, approximately equal to 1. Okay, if you consider more digits here in these values, that is P01 Fishers and P10 Fishers, then this value will come more closer to 1. Okay, so the time reversal test is satisfied by the Fisher's index number. Let us test for the factor reversal test. So we require that P01 into Q01 should be equal to V01. So we are looking at P01 Fishers into Q01 Fishers. P01 Fishers is 1.2324, that is here without the factor 100, into Q01 Fishers. Q01 Fishers is here, so it is 0.8754. If we multiply this, this comes to 1.078. Recall that we had calculated V01 in the previous slides. It was 1.078. What we see is that we get exactly the same value here. So Fisher's index number is the one which satisfies all the tests, in particular the factor reversal test. Laspeyres and Paasches index numbers, they satisfy time reversal test, but they fail to satisfy factor reversal test. And the Fisher's index number is the only one which satisfies all the tests that are required for adequacy of an index number. That is the reason why among the 3 index numbers that we have considered so far, Fisher's index number is considered to be a better one, the best and the most reliable one. So by default, whenever you are asked to calculate or construct an index number, we usually rely on a Fisher's index number.